So we're learning about standard deviation today. It's day 27. We'll start by describing what standard deviation is. Okay, so measures of spread. How is our data spread across our range? As you can see here, the data is less spread out than over here. It's just more spread out. So we don't have to imagine two data sets because I drew a distribution of two data sets. Both of them have the same mean. You can see that the mean right here is the same. So the average value of all numbers is the same for both of them. But one distribution has data points concentrated around the center, which is here. Most of the data is located close to the center. And as we can see, if we see the same range, we don't have the same amount of data. A lot more data is on the outside. The other distribution data has points spread further from the mean. So you can see that this is the mean, and a lot of the data is pushed further out. I have this much data over here, whereas moving up, we barely have any. Okay, the distributions have a different spread. So that's what we're measuring. That's what we're learning to measure, is measures of spread. Okay, so here's an example. So we're using the Dobson unit, which is a measure of thickness of the ozone layer. And we take a bunch of measurements and we get these following values. Okay, so on day 1, we get a measurement reading of 152, day 2, 158, day 3, 151, etc., etc. Now, in order to measure standard deviation, we're just going to go over it without really defining it first. We're going to measure what is the mean, because standard deviation is deviation from the mean. It's how the data differs from the mean, how it's spread away from the mean. So our reference point is the mean. So the first thing we have to do is calculate what the mean is. And what we do is we add up these numbers and divide it by the number of data points. So the total sum of these values is 1083. And if we divide by 7, x bar is the mean, sample mean. Okay, so x bar turns out to be 154.7. So all these data points are surrounding this center value of the mean. That's where they seem to have a tendency to be around that number by definition. Deviation from the mean. Now, the result will be 0 when we add them up, but let's take a look at what that means. I take 152, I subtract it from our mean, and I end up getting negative 2.714. I take 158 and I subtract the mean from 158. That's the mean. We end up getting 3.2857. So we're going to do this for every single point. 151 minus the mean. We get 153, take away the mean. We get 159, take away the mean. So we're trying to see how they differ from the mean. How does each point differ from the mean? And 158 take away the mean, and 152 take away the mean. Now if we add up all these values, by definition, because this is the center value, right? By definition, all of them are going to, if I add these up, it's going to equal 0. So what mathematicians did was, to get rid of these negative numbers, we square it. So we take this value and we square it. So we take each number squared to give us this value. You can verify with your own calculator. So what do? We take this value and we square it. What do we end up with when we add up all these numbers? We end up with 71.43. And this is if I divide this by the number of data points, I get the variance. So, or something like the variance. Okay, so this is S squared is equal to 71.43 divided by 7, number of points. And as you can see, the variance of the square deviation is 10.2. Now, to get the standard deviation, if I take the square root of the variance, I get the standard deviation. And basically it means that much of the data is within 3.19 Dobson units. And as you can see, a lot of them are within or close to 3.19. On average, that's what they're going to be, close to an average. Okay, that's not exactly what standard deviation is, but you can think of it at this point as the average deviation of all the points from the mean. Okay, so here are your definitions. You can write them down. The average squared difference of the scores from the mean. And then standard deviation, the square root of the variance. The average distance of the scores from the mean. Okay, so you just take the square root of the variance. So we can say that variance, the square root of the variance, equals the standard deviation. Standard deviation uses the same units as the data. Variance is expressed in square units, right? Because it's S squared. And now here is the formula for population variance. Essentially what we did was we calculated, right? The first step was to calculate the average. Then for each point, right, we took the difference between the average and each point and we squared it. And then this means we add them all up and then divide by n. And then the standard deviation, once we have, r is equal to square root of r squared. And if you notice this, let's get rid of some of the markings. This here is equal to that, right? So this is just the square root of that. Okay, and then we have the sample variance, which is a little bit different, but the same process almost. Calculate the mean for the sample, x bar, which is the same thing as mu, except this is for sample and this is for population. Then we take the difference for every point. For every point, we calculate the difference between x bar and the mean, and the point, x bar and the point. We square it, and then we add them all up. And when we're done, we divide by n minus 1. We'll talk about why not n minus 1 before we did divide by n, but why n minus 1? We'll talk about that in a second. And then standard deviation is just the square root of the variance right here. Why n minus 1? Okay, so we talked about this in class. Samples rarely contain extreme values when compared to entire populations. So because populations have more extreme values, mathematicians just decided, or actuaries or what have you, statisticians just decided to make this spread a bit bigger by making the denominator a little bit smaller, right? So by making this smaller, the whole thing gets bigger, which means I have a bigger spread to account for the fact that populations will have extreme values. So this is probably, without this minus 1, this will probably be smaller than it needs to be. Okay? So here's an example of something that you would go over to check your understanding. So I have two quizzes. These are the quiz scores, right? 4, 5, 6, 7, 8, 9, and 10. And here it only goes from 5 to 9. Which quiz would have the greater standard deviation and why? The variance of quiz 1, if we calculate the variance of quiz 1, the variance of quiz 1 is 1.5. What is a standard deviation? Well, you just take the square root of that. What would quiz 1 graph look like if the standard deviation were 1.6? So if quiz 1 was 1.6, so the square root of that is approximately 1.22, right? So what would it look like if scenario 2, if r equals 1.6? Well, 1.6 is more than 1.22, so it would be more spread out. It would look more like quiz 2. What would the graph look like if the standard deviation were 0? Okay, so we're going to explore all these questions. So which quiz would have a greater standard deviation? Quiz 2 is more spread out, right? So if the center is here, we're spread out from 4 to 10, right? So that's going to have a greater standard deviation. This only spreads from 5 to 9, right? So quiz 1 will have a lower standard deviation. Quiz 2 has a greater standard deviation because it is more spread out than quiz 1. Simple as that. The variance of quiz 1 is 1.5. What is the standard deviation? Well, the standard deviation is a square root of the variance. Okay, so what do? We just take the square root. So r is approximately 1.22. What would quiz 1 graph look like if the standard deviation were 1.6? If the standard deviation was 1.6 instead of 1.2, it would be more spread out. Simple as that. Standard deviation represents the spread. If you tell me it's larger, then it would be more spread out. It would look more like graph 2, more spread out because it's a greater standard deviation. What would the graph look like if the standard deviation was 0? So this is a representation of standard deviation from the mean. If I have a value of 0, I have no deviation from the mean. So that means all values will equal the mean. There would be no spread. All the data would be equal to the mean. Simple as that, right? All the data would be 7 or wherever the mean was. There would be no deviation. It'd be exactly the same. So calculate the standard deviation of quiz 2. So the first thing we want to do is calculate the mean, right? So step 1, calculate the mean. So I have all my data points, 2 4s, right? So how many 4s? 2. I'm going to have 4 5s. 4 5s right there. I'm going to have 3 6s. 3 6s. I'm going to have 3 7s. Those are 3 7s. 2 8s. 2 8s. 3 9s. And 3 10s. So if I calculate the mean, I have to add these all up and divide by the number of data points. So there are 20 data points. Add them up. I get 140 over 20. My mean is going to be 7. My standard deviation is take every point and subtract it from mu and square it. And then add them up. So what does that look like? Well, where did I get this 9 from? Essentially, that is 4 take away 7, which is minus 3, squared is equal to 9. And we have 2 of those, right? 2 9s. Let's delete some of this markings. And now, where do these 4s come from? They come from these 4 5s. Essentially how we calculated them was 7 take away 2. Oops, sorry, 7 take away 5. Let's write that again. 7 take away 5 square, which is 2 square, which is equal to 4 for each of them. And then here I have 3 6s. 7 take away 6 squared. What do we end up getting? We end up getting 1 squared, which is how we account for these 3 1s. And these 3 7s, 7 take away 0. Sorry, what do I keep doing that? 7 take away 7 is equal to 0. 0 squared is 0. These 2 8s, 7 take away 8 squared is minus 1. That's how I got these 2 1s. And then these 9s are 2 away from the mean. So 2 squared is 4. And these 10s are 3 away from the mean. So that's 9. And then we divide by the number of data points. Okay? Essentially, we end up getting 78 over 20. To get the standard deviation, which is 3.9, to get the standard deviation, we take the square root. And our standard deviation is 1.975. And that's how you do. So that's a mean. Most of the data is within 1 standard deviation. Much of the data. And that's it. Okay, so my standard deviation here, that's 1.5, right? Much of the data is there, right? If I take this range over here for quiz 1, quiz 2, most of the data, that's 1 standard deviation. So the mean plus 1 standard deviation and the mean minus 1 standard deviation. It goes from 5.02 to 8.98. And if we counted the data points, there would be 15 data points, right? 4 plus 3 plus 3 plus 2 plus 3. So if we add these up, 3 plus 3 plus 3 is 9, 11, and 15 data points can be found within 1 standard deviation of the mean. The same is true here. I have 6 and 5 and 4. I also have 15 data points. So what the standard deviation measures is where can much of the data be found? And it'll capture on average the same amount of data points, but how much range do I need? That's what standard deviation kind of answers. How much range do I need to capture a certain amount of data points? Like, what's the spread? Okay, now we move on to Z-scores. In fact, we'll do that in another video.